So here is the LEETCODE question 3741, and by the way, the first question and second question are basically both the same thing, and there's just a slight optimization, a slight intuitive thinking which you have to apply to make it work for both the questions. So basically have a same code for both the questions. So the question is minimum distance between the equal elements. That is, let's say there's an array like 1 2 1 1 3. Now we'll have to find 3 elements in the array which are same. So let's say this is I, and this is J, this is K. Okay, now all these 3 are same. Now our aim is to find the minimum difference. What is difference? Difference is nothing but the absolute value of the difference between I minus J and J minus K and I minus K. And if you don't know what absolute is, if you get a negative value, it gets converted into a positive value. So your aim is to minimize this possible distance, and if there's no such elements where 3 elements are equal in the array, then you basically return -1. Okay, so how do we do it? In the very first start, in the first question, our constraints say it's up to 100 in fact. So you can brute force it. Time complexity would come up to O(n) cubed in the worst possible case. That is, as I told you, 1 2 1 1 3. We will run a I loop over here, and we'll run a J loop over here, and we'll run a K loop over here. That is, I will be the first element to be checked, and J will be the next element, and K will be the third element. So likewise, you can run a loop for O(n) cubed times until you meet a condition where nums of I equals nums of J equals nums of K, and then you can keep initializer answer equals whatsoever. Let's say for now we'll keep it as the maximum possible value, that is float of inf, that is nothing but infinity in Python, or in case of C++ you can say int underscore max, all in caps. Okay, and until then it's clear, and basically the obvious part, that's ABS of I minus J plus I minus K and so on, and the minimum value amongst that, answer, right? Okay, so this part was like pretty obvious and clear to all of us, but how can we optimize it? That's where hashing dictionary comes into play. We can store 1 1 1. Let's say this is the test case, right? 2 2 1 3 2 1. Okay, so we can store all these elements inside a dictionary. That is the frequency of these elements. So dictionary, let's say this is the dictionary. So 1 would have 1 2 3 4 5. So the frequency is 5, and for 2 it's 3, and for 3 it's 1. Now we have maintained the frequency, right? Meanwhile, with a single run of loop where we initialize the frequency, we can also keep another dictionary which stores the indices, the index position of all these elements. So for 1 it would be, so 0 basically makes it, so 0 1 2 3 4 5 6 7 and 8. So 1 would be storing 0 1 2 5 and finally 8. Okay, and then 2 would be storing 3 4 and 7, and 3 would be storing just 6, right? So here we have got both the frequencies and the index values. Now it must be pretty obvious to you what you should do. You can iterate over this dictionary D1, and only for those values whose frequency is greater than or equal to 3, that is the frequency of any element is greater than or equal to 3, you will iterate inside this dictionary. So D1 of I, okay? So when you iterate inside D1, it will be for I in D, right? This I indicates this value. So then you can iterate over the second dictionary with D2 of I. This would give you a list. d2 of I would give you a list. That's basically this list when we take 1 as the value. And then we can just skip the last values. We can run a loop from 0 to len of that current array minus 2. Why? Because we'll have to check with each and every possible sets of tuple. So this would be one tuple, this would be one tuple, this would be one tuple. I'll make it much more clearer in drawing. So let's say this was the previous value of dictionary. Okay, I might have messed up with the values, but let's just assume this was the frequency and the indices. Okay, so we'll be only checking first of all 1 and 2, because 3 has only one particular frequency, so we can skip that, right? And then we can, in fact, you don't even need to store the values of the frequency of all the dictionary, right, of all the values, because basically the array would directly tell you the size. So it was just for intuitiveness. This is much more a better practice. You would save a lot of space in this. You would save O and space in this. But anyways, moving on. So we will have to check each and every tuple 0, 1, 2 and 1, 2, 5 and 2, 5, 7. That's why we run a loop from 0 to n minus 2, where n is the size of this particular array, because the last two value will be skipping, because how you would be accessing this I, and you will be accessing I plus 1 and I plus 2. So when you come over here, this particular part, you'll be accessing I, which is this, I plus 1 and I plus 2. So in case if you take this value and you run a loop towards the entire size of the array, you would hit out of bounds, which will give you error. So you run a loop from 0 to n minus 2. Like that, you would be continuously updating the value of answer with the obvious value a base of I minus j, j minus k and k minus I, and that's your answer. So let's move on to the code. So here is the C++ code for it, where we start by declaring a dictionary with int as the key and vector int, that's the list, as the value. And then we run a for loop inside the array, and with each and every element we push back the indices of each and every element inside the dictionary. We start with an answer variable which will store the final answer, and primarily it will be storing the infinite value, and we'll iterate inside the dictionary. And if in case the array size of any element is greater than 2, that's if its equivalent are greater than 3, then we'll check for each and every set of 3 tuples, tuples with size 3, and we will be incrementing the value inside the answer if it satisfies the given operation as mentioned earlier. And finally we'll be printing the answer if the final answer is not equal to int max. If it is equal to int max, which means infinity, we'll be just printing -1. So that's pretty much it. And I'll just show the Python code as well once. So this is the Python code, the dictionary, and then appending, and the very same operation as done earlier. So we can just submit the code once again, and here it goes.